and in this lecture we are going to discuss about the second chapter, okay, SSC physics, okay, second chapter, that is chemical equations. So in the chemical equation, this is a lecture 2. This is a lecture 2 of the chemical equations. So here we are going to discuss about how to write the chemical equation and how to balance the chemical equation. That is our today's topic. Okay, and by the way, good afternoon everyone, and make sure if you have any doubts or questions, post it in the live chat section so that I can read and I can reply to your doubts or questions. Okay, so now we will discuss about the chemical equation, and yes, good afternoon everyone, good afternoon. So first, what is chemical equation? Okay, so chemical equation, it is nothing but writing the products and reactants, how they react and what products they obtained, that is known as chemical equation. So in this diagram, in this equation, you can see calcium oxide and water, they are chemical substances, and when they react, they are going to form a products. So such kind of reaction or such kind of reaction in chemical substances is known as chemical equation. So the chemical equation is representation of the chemical change. So what is meant by chemical change? Chemical change is nothing but turning of one substance into another new substance, that is known as change, chemical change. For example, here you can see the calcium oxide is there and water is there. Calcium oxide, okay, CaO and also plus H2O, okay, both are going to react to form a calcium hydroxide, okay, calcium hydroxide. So this is known as chemical equation. This is chemical equation, it is a chemical change. So here you can see calcium oxide and water, they are changing into new substance, completely new substance, that is calcium oxide. So this is known as chemical change. Okay. So these chemical equations are written in chemical formula. Okay. What is meant by chemical formula? Okay. If you want, if I ask you to write water molecule, okay, you will write WA. Okay, T or water. Okay, it is a word. So if I ask you to write the chemical formula for the water, you have to write H2O. Okay, why? Because the water is going to contain 2 hydrogens and 1 oxygen. So this is the chemical formula. Each and every chemical substance, whether it may be water, whether it may be oxygen or anything, so they are going to have hydrogens. They are going to have the respective atoms. Okay. So example, in case of water molecule, you can see hydrogens and oxygens, okay, and in case of calcium oxide, okay, you can see calcium and also oxygen. So these are the atoms that are present in the chemical formula, okay. So the chemical equations, the reactants are written on the left side of the arrow and products are written on the right side of the arrow. So here the equation, the chemical equation is nothing but how the chemicals are going to form into new substance or how they are going to change into a new substance, that is known as chemical equation. Okay. So here what we are saying about the products and also reactants. So what is meant by product? So in the chemical equation, so we are writing in form of chemical formula. So example, calcium oxide plus water, okay. So they are going to react together to form calcium hydroxide, okay, calcium hydroxide. So here you can see from here to here, they are reactants, okay, they are reactants, okay, and from here the product that you form after the arrow, they are known as products, okay, they are known as products. So reactants are nothing but, so before the arrow, whatever the chemical substances are present, they are known as reactants. Here you can see the 2 reactants are there. They are calcium oxide and also the water molecule. They are the 2 reactants. And at the end, after the arrow, that is on the right side, you can see product, that is calcium hydroxide. So it is a product. So before the arrow, reactants, and after the arrow, you will see the products. Okay. So this is about the chemical equation. Okay. So here the plus sign is used. Okay, the plus sign is used to indicate more than one reactants or products are present. So here what we have used, the plus sign indicating that more than one. Okay, more than one reactant or product. In case of reactants, in the calcium oxide and also water, so both two are there, two reactants are there. So hence to denote two reactants, we have used the plus symbol, okay, or plus sign. So in the products, we did not use any plus sign. Why? Because it is only one. Okay, in case of only one product, there is no need to use any sign like plus sign or anything else. Okay. So next is the chemical formula constitutes the element include symbols, subscripts, numbers, atoms, etc. So first we will discuss about symbol. Okay. So each and every atom in the periodic table has certain elements. So example, if you take hydrogen, okay, Hydrogen, hydrogen, okay, this is a word for the element. So what is the symbol for this element? The symbol for this element is H, simply H, okay. If you write H simply, it is a formula or it is a symbol for the hydrogen, okay. So in the chemical equation, so the symbols are present and subscripts also present. So hydrogen, if two hydrogens are present, that is H2. So it is subscript, means below the word. This is a subscript, like oxygen, O2. Okay, it is a subscript. Subscript means just slightly below the symbol, whatever the number is present, that is known as subscript. Okay, that is known as subscript. And number of atoms. Okay, number of atoms means how many atoms are there. For example, if I say, so 2 oxygen molecules, I will write 2 before the oxygen. That is, how many oxygen molecules are there? 2 oxygen molecules are there. So by this way you can write. Okay. And by the way, if you have any doubts or comment, or if you have any doubts or questions, feel free to post in the live chat section so that we will discuss about your doubts or your questions. Okay. Okay, fine. So if no subscript is written, it is considered as 1. Okay. So for example, you can write zinc. Okay, zinc. In the zinc there is no subscript. There is no subscript like 1, 2, 3, and so on. So what does it indicate? It indicates that only one zinc molecule is present. Okay, if you write Z and 2 subscript, it is indicating that the 2 zinc molecules are present. Okay. So hence, or you can write here also H2. Okay, H2 means 2 hydrogen molecules are attached. Okay, so 2 hydrogen atoms. So this is about it. And example here you can see calcium oxide. So before the calcium oxide no number, and after the calcium oxide also no number. So hence calcium oxide plus water molecule is going to react together to form calcium hydroxide. Next, zinc plus HCl. So they are going to react together to form zinc chloride plus hydrogen atoms, so and so on. So this is also another example is sodium sulfate and also barium chloride. They are going to react together to form barium sulfate and also sodium chloride. So these are the few examples for the chemical equation. Okay. Next is the balancing chemical equation. In chemical reaction, the atoms neither created nor destroyed, means no new atoms will be produced during the chemical equation and no atoms will get destroyed or disappeared during the chemical equation. So what is happening here? The atoms will change from one form to the another form. It means one form to the other form. Okay, other form. For example, here you can see zinc plus HCl. So when they react, what will form? There is a formation of zinc chloride. So hydrogen is going to turn, means from the hydrochloric acid, hydrogen is going to turn into gas and they are entering into the atmosphere. It means here you can see hydrogens previously in the form of liquid. Okay, in the form of liquid, that is in the acid, it is in the form of liquid. So it means the liquid form of hydrogen is turning into gaseous state. So this is the indication and clear example for the atoms will not get destroyed or atoms will not get created during the chemical equation. So, but they may change from one form to another form, or they may turn in one chemical substance to the another chemical substance. Okay, this is chemical equation. So, according to the law of conservation of mass, the total mass of a product must be equal to the total mass of reactants consumed. Okay, so whatever the reactants are there before the arrow, okay, let us say certain, okay, some x number of atoms are there, x number of atoms, and after the reaction also the atoms should be same x number of atoms. So let us consider 100 atoms are there before the reaction, and after before the reaction, that is in the product side, the same 100 atoms should be there after the reaction. Okay, they may change into other substances or other state. Okay, it doesn't matter, but the atom should not get decreased or atom should not get increased during the chemical equation. Okay, and remember one thing, each atom constitutes the mass of the product. For example, if you take a glass of the water, let us consider the glass of the water is around 250 grams. Okay, so 250 grams. So here each and every water molecule in the glass is going to constitute some weight. Okay, each and every water molecule in the glass is going to have some weight, whether it may be negligible. Even though the weight is negligible, it is going to provide some amount of weight to that water. Okay, and next is the balanced reaction indicates the number of atoms on the reactant side, that is left side, are same on the product side, that is right side, which involves the formula unit. So one of the most important thing is the formula unit. What is formula unit? So the number of atoms present in the chemical substance, that is known as formula unit. Okay, so reactants are equal to the products. It means here there is small correction, that is the number of, not reactants and products, the number of atoms in the reactant side should be equal to the number of atoms on the product side. Okay, so APS giving the number of reactants, the number of atoms in the reactant side should be equal to the number of atoms on the product side. Okay, so you are almost correct, but small correction. Okay, you are correct. So formula unit of a substance corresponds. Okay, Sony. So the formula unit. Okay, formula unit of substance corresponds to 1 unit. Okay, of a given formula. Okay, so for example, if you take NaCl, sodium chloride. Okay, if you take the sodium chloride, so here how many sodiums are there? 1 sodium. Okay, and 1 chlorine. So in the sodium chloride, 1 sodium and 1 chlorine is there, that is known as formula unit. So hence you can say Na plus and Cl minus. So what is meant by Na plus and Cl minus? Here you can see there is a charge, that is known as ion. What is meant by ion? What is meant by neutral atom? For example, Na, sodium. Okay, it is in the natural state, it is in the neutral form. Okay, when it loses 1 electron, okay, when it loses 1 electron, it is going to turn into Na plus. Okay, losing of electron. Okay, that is, it is going to gain positive charge. It is known as ion. Ion is nothing but a charged species. So see here the chlorine minus. Chlorine is going to accept 1 electron. It is going to have a charge known as Cl minus. Here it is a negative charge. See here, what I said just now, ion is nothing but a charged species. Okay, when an atom loses an electron or gains an electron, then they form ions. Okay, so sodium ion and also chlorine minus, Cl minus ion. So if they don't lose or they don't gain electron, then that is known as neutral atom. Okay, that is known as neutral atom. Neutral atoms will not lose electrons or will not gain electrons. When the neutral atoms loses or gains electrons, then they are going to turn into ions. Okay, So here the formula unit of NaCl is 1 Na plus and 1 Cl minus. This is the formula unit. And the formula unit of MgBr2 has 1 Mg2 plus. Okay, 1 Mg2 plus. Remember, this is an ion. Why? Because it has lost 2 electrons. Okay. And next is the Br. Okay, Br minus means so 2 Br. Okay, 2 Br minus ions. Next is the formula unit of H2O is 2 hydrogens and also 1 oxygen. So this is about formula unit. Formula unit means how many number of atoms and what are the number of atoms present in the chemical compound is known as formula unit. Okay. Next one is a balance, steps to balance the chemical equation. Just now we have discussed what are the chemical equations and how they are written and what are the reactants, what are the products, everything we have written, everything we have discussed. Now we are going to discuss about the how to write the chemical equation and how to balance the chemical equation that we are going to discuss in here. So the first, there are few steps, like 4 steps. So listen step by step and you will come one idea, you will come to know how to balance the chemical equation. Okay. So step 1, it is write the skeleton equation using correct chemical formula. So what is meant by chemical equation? The chemical equation is nothing but rough formula. Okay. So here without any balancing, whatever the chemical equation that you write, that is known as chemical equation. So for example, we will discuss with examples later. So next step is count the number and compare the number of atoms on both sides. So both sides of the arrow, on the left side and right side, you have to count it. So first one is the skeleton formula or skeletal formula. Second one is the counting the number of atoms on the both sides, left side and right side. So next is to find the coefficient to balance the equation, means you have to find out how many atoms are required to balance the equation. Okay. So for that we have to start with most complex substance in the equation. Okay, in the substance in the skeleton equation. Third one is make sure coefficients are reduced to the smallest whole number. Okay, there should be smallest whole number value. Next is to count the number of kinds of atoms on both sides and the equation. This is nothing but it is equal to the step 4 is equal to the step 2, almost equal. So based upon the 4 steps that we have discussed just now, we will try to solve some questions. Okay, we will try to solve some examples. So first example is the formation of water molecule. So water molecule, here you can see the hydrogen is going to combine with oxygen to produce water molecule. Okay. So here hydrogen and oxygen are reactants, not reactants, reactants. Okay. So and water molecule is formed. Okay. So water molecule is a product. Okay. So see here the first step 1. What is step 1? Step 1 is to write the skeleton equation. Okay. So for the water molecule, the skeleton equation will be H2, hydrogen and also oxygen. So hydrogen plus oxygen, they react. They are the reactants. They will react together to form water molecule. We know that water molecule formula is H2O. Okay, we have to write the correct chemical formula. Okay, so now is it balanced? Okay, is it balanced? It is not balanced. Why? Because on the reactant side, how many hydrogens are there? 2 hydrogens. On the product side, 2 hydrogens. It is okay. What about oxygen? Only 1 oxygen is there here and 2 oxygens are there here. So we have to balance it. So again write the chemical equation. H2 plus O2 gives rise to H2O. Okay. So what will be, how many atoms you need, how many oxygens you need? You need 2 oxygens. Okay. Put 2 over here. Okay. 2 H2O and put 2 hydrogens over here. Okay. 2 hydrogens. So now count the number of atoms. So how many hydrogens are there? 4 hydrogens. Okay. And also how many oxygens? 2 oxygens. Okay. 2 oxygens. Here how many hydrogens? 4 hydrogens. Here oxygens how many? 2 oxygens. Okay, so the balance, the equation is balanced. What we have written, the first we have written the skeleton equation, and after that we have arranged, we have made the we have added some atoms. Okay, we have balanced the chemical equation by putting some numbers before the equation. Remember one thing, you should never change the subscript. You have to add only the atoms, that is before only you have to put the numbers. After the numbers, after the symbols, you should not put any number. Okay, so this is about balancing the chemical equation for the water molecule. So next one is the combustion of propane. Okay, so what is propane? It is a fuel. It can be used for the cooking purpose, or it can be used for the heating purpose. Okay, so this is about the propane. It doesn't have any color and doesn't have any odor. Okay, so that is about the propane. Propane is colorless, odorless gas after use the cooking purpose, and also for the fuel or heating purpose. So the propane and oxygen are the reactants. What are the propane and oxygen are the reactants? Propane, here you can see the propane, like you can see it's C3H8, formula is C3H8. The propane is going to react with oxygen, okay, to give rise to what? To give rise to carbon dioxide plus water. Okay, so these are the products and reactants. These are the reactants and these are products. Okay, so this is about the combustion. This is about the combustion of the propane. So now we have to balance it. How do you balance this? We have written the skeletal equation. Okay, it's fine. We have written the skeletal equation. So now we have to balance it, like C3H8 plus O2 gives rise to carbon dioxide plus water molecule. Okay, so now count the number of atoms. So how many carbons are there on the left side? Only the 3 carbons are there. Okay, how many carbons on the right side? Only 1 carbon. So now put the 3 carbons over here. 3 carbons. So 3 CO2. Okay, and water molecule. Okay, it's fine. So again it is not balanced. Okay, again it is not balanced. Okay, so how many oxygens? 2 oxygens. Here is how many oxygens are there? So 2 3 2 6 oxygens are there. It is not balanced. So again we have to add some other thing. So again write the chemical equation. C3H8 plus O2 gives rise to 3 CO2 plus H2O. Okay, so right here. So just now we have seen the oxygens are not balanced. So add 4 over here. Okay, so how many oxygens are there? So 4 oxygens are there. So now count the number of oxygens. So 6 oxygens. So plus how many oxygens are there? 4. 6 plus 4, 10 oxygens are there. Okay, so here how many? So 2 oxygens only is there. So again we have to add the chemical substance. We have to increase the number of atoms. So C3H8 plus O2. How many atoms are there? Here is 10 atoms, 10 oxygen atoms. So we have to add 10 here. It means 5 2s are 10. Okay, 10 oxygen atoms. So again 3 CO2 plus 4 H2O. Okay, so this is a chemical equation. So hence we have found that by adding 5 oxygen atoms before the 5 before the oxygen in the product side, we can balance the chemical equation in this way. Okay, so you can write the chemical equation in this way also. Okay, C3H8 plus 10 O2 gives rise to, okay, 6 CO2 plus 8 H2O. Okay, so this also it may be correct, but what we have discussed in the steps, it should be smallest whole number. Okay, smallest whole number. So it means we have to divide the 10 by 2. Okay, that is nothing but 5. So this is the reason we are not writing this chemical equation. We have to make sure that a smallest whole number we have written in this way. Okay, so next one will be the aluminum trioxide. Iron oxide reacts with aluminium. So we have to write it. Okay. So here Fe2, here Fe2O3. Okay, iron Fe. Okay. So 2O3. Okay, iron trioxide plus aluminium. Okay, Al gives rise to Fe, that is iron, plus Al2O3, aluminium trioxide. So this is formed. So we have to balance it. First, what we are going to see, we are going to see that first balance the iron. Why? Because we have to, in the steps we have seen, the first see the complex one, complex chemical compound. Here the Fe2O3 is a complex one. So see the iron. How many iron atoms are there? 2 iron atoms are there. So add 2 irons here. Okay. So add 2, number 2 over here. So here it is again, it is not balanced. So Fe2O3, again write the equation, plus Al. Why? Because here 2 aluminiums are there. So put 2Al. Okay. 2Al gives rise to 2 iron atoms plus, so Al2O3. Okay. So this is a chemical equation. So check whether all atoms are same or not. Okay. So all atoms are same. Okay. Fe2O3 plus 2Al to Fe Al2O3. So if you count the number of atoms, all are equal. So 2 aluminiums, 2 aluminiums. So 3, how many oxygens? 3 oxygens. Here also the 3 oxygens. So next, how many iron atoms? 2 iron atoms, 2 iron atoms. How many aluminum atoms? So just now we have discussed the aluminum also over. Okay, by this way we can balance the chemical equation. So this is how you balance the chemical equation, and I hope this lecture is helpful to you. If you have any doubts or questions, post it in the comment section so that we can discuss about your doubts or questions. And tomorrow we will discuss, means in the next lesson we will discuss about the making the chemical equation more informative. Okay, that we will discuss in the next class. Okay, and okay, fine.